Tunneling under extreme conditions, real engineering. Hello everyone, welcome to Tech Hand. In this video, we'll be exploring the world of tunneling under extreme conditions. From digging through mountains to crossing under the sea, tunnels are an essential part of modern infrastructure. But what happens when the conditions are more extreme? How do engineers and construction workers tackle the challenges of tunneling through hard rock, under high water pressure, or in freezing temperatures? Thanks for watching, and don't forget to subscribe. Let us know in the comments that you're subscribed and what you think of this video. We'll reply to you personally. You can also give a thumbs up. Thanks for that. Tunneling. Tunneling is the process of excavating a passageway or tunnel through soil, rock, or other materials, typically underground. Tunnels are often used to create transportation routes, such as highways, railways, or subways, or to facilitate the movement of resources such as water, oil, or gas. They can also be used for storage, shelter, or to provide access to hard-to-reach places. Tunneling can be a complex and challenging engineering feat, requiring careful planning, design, and construction. Engineers must consider factors such as geology, water table levels, and environmental impact when deciding on the best tunneling method and materials to use. There are several methods of tunneling, including cut and cover, bored tunneling, and immersed tunneling. Each method has its own advantages and disadvantages, and the choice of method depends on factors such as the type of ground to be excavated, the length of the tunnel, and the level of water pressure. Tunneling under extreme conditions such as high water pressure or freezing temperatures requires specialized equipment and techniques. Engineers may use advanced drilling machines, tunnel boring machines, or specialized excavation techniques to overcome the challenges of these conditions. Challenges of tunneling under extreme conditions. Tunneling under extreme conditions presents a number of challenges for engineers and construction workers. Tunnels constructed under bodies of water, such as rivers or oceans, must contend with high water pressure. The pressure can cause the tunnel to flood or collapse, making it difficult to construct and maintain. Tunnels built in regions with extreme temperatures, such as the Arctic or desert regions, pose unique challenges. Cold temperatures can cause the ground to freeze, making excavation difficult. Meanwhile, extreme heat can lead to dangerous working conditions and equipment failures. Tunnels built in regions with hard rock and geologic instabilities, such as earthquakes or landslides, can be difficult to excavate and maintain. These conditions can also pose safety risks to workers. Tunnels built in areas with hazardous materials, such as toxic waste or gas leaks, require special precautions to protect workers and the environment. These precautions can add time and cost to the construction process. Specialized techniques for tunneling under extreme conditions. To overcome the challenges of tunneling under extreme conditions, engineers and construction workers have developed specialized techniques and equipment. Tunnel boring machines, TBM. Tunnel boring machines, TBMs, are massive machines that are used to excavate tunnels quickly and efficiently. They are particularly useful in tunneling projects that involve hard rock, high water pressure, or other challenging conditions. TBMs work by using a rotating cutting wheel to excavate the rock or other materials in the tunnel path. As the wheel rotates, it grinds the rock into small pieces, which are carried away by a conveyor belt or other transport system. TBMs can also be equipped with a system that injects grout or other materials to reinforce the tunnel walls as they are excavated. One of the key advantages of TBMs is their speed and efficiency. They can excavate tunnels much faster than other methods, such as drill and blast, which can take longer and require more labor. TBMs also produce less noise and dust than other methods, making them a more environmentally friendly option. There are several types of TBMs, including shield TBMs, open-face TBMs, and double-shield TBMs. Shield TBMs are used in soft ground conditions, while open-face TBMs are used in harder rock. Double-shield TBMs are a hybrid between the two, designed to work in a range of conditions. TBMs require specialized knowledge and expertise to operate, and they can be expensive to procure and maintain. However, for large-scale tunneling projects, they are often the most efficient and cost-effective option. Drill and blast method. The drill and blast method is a technique used to excavate tunnels in hard rock conditions. It involves drilling holes into the rock, placing explosive in the holes and then detonating the explosives to break up the rock. The drill and blast method typically involves a team of workers who use drills to create holes in the rock face. Once the holes have been drilled, explosives are inserted into the holes and then detonated. The resulting blast breaks up the rock into smaller pieces, which can then be removed using heavy equipment, such as loaders and trucks. One advantage of the drill and blast method is that it can be used in a wide range of conditions. It is particularly useful in hard rock conditions, where other methods such as TBMs may not be effective. The drill and blast method can also be used to excavate tunnels of various sizes and shapes. However, the drill and blast method can also be dangerous and requires careful planning and execution. Workers must take precautions to prevent accidents and ensure that the blast does not cause damage to nearby structures or the environment. The method can also be noisy and produce dust and other airborne particles, which can pose health risks to workers and nearby residents. Overall, the drill and blast method remains an important technique for tunneling in hard rock conditions. It requires specialized knowledge and expertise to execute safely and effectively. Ground freezing technique. The ground freezing technique is a specialized tunneling method used in areas with difficult ground conditions, such as permafrost or unstable soil. The technique involves injecting refrigerant or other cooling agents into the ground to freeze the soil and rock, creating a temporary structure that can be excavated. To use the ground freezing technique, engineers drill a series of boreholes around the area where the tunnel will be excavated. They then insert refrigerant pipes into the boreholes and circulate the refrigerant through the pipes, lowering the temperature of the ground around the boreholes. As the ground freezes, it becomes harder and more stable, creating a temporary structure that can be excavated. Once the tunnel excavation is complete, the refrigerant is removed from the ground, allowing it to thaw and return to its original state. In some cases, grout or other materials may be injected into the ground to reinforce the tunnel walls and provide additional stability. The ground freezing technique can be effective in areas with permafrost or other difficult ground conditions, but it is also expensive and time-consuming. It requires specialized equipment and expertise to execute, and it can take several months for the ground to freeze and stabilize. However, for certain tunneling projects where other methods may not be effective, the ground freezing technique can be a valuable tool for engineers and construction workers. Immersed tunneling. Immersed tunneling is a tunneling technique that involves constructing tunnels underwater or in other areas where it is not possible to excavate a tunnel using traditional methods. The technique involves prefabricated tunnel sections on land and then sinking them into place in the water using specialized equipment. To construct an immersed tunnel, engineers begin by designing and fabricating precast concrete tunnel sections in a dry rock or other fabrication facility. The sections are typically rectangular and cylindrical in shape, with a hollow interior that will serve as the tunnel bore. Once the sections are complete, they are transported to the construction site using barges or other large vessels. At the construction site, the tunnel sections are lowered into place in a trench that has been prepared on a seabed or riverbed. Specialized equipment is used to carefully position and align the sections, ensuring that they fit together seamlessly. Once the sections are in place, they are sealed using a combination of grout, bolts, and other materials to create a watertight tunnel. Immersed tunneling is particularly useful in areas where it is not possible or practical to excavate a tunnel using traditional methods, such as in the deep water or in areas with unstable soil conditions. The technique is also less disruptive to the environment than other tunneling methods, as it does not require extensive excavation or tunneling under existing infrastructure. However, immersed tunneling is also a complex and expensive process. It requires specialized equipment and expertise to excavate, and the prefabrication and transportation of the tunnel sections can be time-consuming and costly. Despite these challenges, immersed tunneling remains an important technique for constructing tunnels in challenging conditions. Are you enjoying our video? Before we continue with the video, please make sure to click the subscribe button and hit the bell icon. Also, turn on the notifications so you don't miss out on more amazing videos from us. Let's continue to see the tunneling under extreme conditions. Future of tunneling under extreme conditions. Tunneling under extreme conditions, such as deep underground, beneath the ocean floor, or in extreme climates, will continue to be a critical aspect of infrastructure development and resource extraction in the future. The future of tunneling under extreme conditions will be shaped by advances in technology, new materials, and a growing focus on sustainability and efficiency. One area of innovation is in the development of new tunneling machines that are more efficient and versatile. These machines use advanced sensors and computer algorithms to navigate complex terrain and adapt to changing conditions. They also use new materials that are stronger and more durable, allowing them to operate in extreme conditions. Another area of innovation is in the development of new construction techniques that are more sustainable and efficient. For example, some companies are experimenting with using 3D printing technology to create tunnel walls and supports, which can reduce waste and lower cost. In addition to technological advances, the future of tunneling under extreme conditions will be shaped by a growing focus on sustainability and environmental impact. There is increasing demand for infrastructure projects that are designed to minimize their impact on the environment and reduce greenhouse gas emissions. As a result, tunneling projects will need to incorporate more sustainable materials and construction techniques, such as using renewable energy sources and recycling construction waste. Thanks for watching. Don't forget to subscribe. Let us know in the comments that you're subscribed and what you think of this video. We will reply to you personally. You can also give a thumbs up. Thanks for that.